Welcome to the Explainer. Today, we're diving deep inside one of the most powerful enterprise databases on the planet, Oracle. We're going to follow a single request from the very moment you hit enter all the way to the moment that data pops up on your screen. So what really happens when you do that? You might think, oh, it's just a simple lookup, right? Well, not quite. It's actually a carefully choreographed dance through an incredibly complex system, one that's been meticulously designed for two things: blistering speed and absolute safety. All right, so to really get this, we've got to start with the most fundamental idea about an Oracle server. You see, it isn't one single thing. It's actually two very distinct parts that work together in perfect harmony. On one side, you've got the instance. The best way to think about this is like a super busy, high-speed workshop. It's active, it's fast, and it lives in your computer's temporary memory, the RAM. And then, on the other side, you have the database itself. This is your permanent, super secure library, safely tucked away on your disk. Pretty much everything we're about to see is just a conversation between this workshop and this library. Okay, let's get into the nitty-gritty. We're going to follow a single request from start to finish, and it all begins the instant a user, or maybe an application, decides it needs some data. They are essentially knocking on the virtual door of the Oracle server. When you connect, your app kicks off something called a user process. Now, this process doesn't go barging into the server itself, oh no. Instead, it talks to a dedicated representative, a server process, that's already waiting on the database machine. This server process, think of it as our query's own personal guide for this whole trip. Okay, so where does our little query go first? Right into that high-speed workshop we talked about, the instance. And more specifically, it heads for a big, shared chunk of memory called the System Global Area, or SGA. This is the real nerve center of the whole operation. So, the server process takes our SQL query to this really clever spot in the SGA called the shared pool. Now, you can think of this place like a communal workspace with an amazing memory. Its whole job is to avoid redoing work that someone else has already done. And right here, the whole system pauses and asks this one super important question that changes everything. Have we seen a query exactly like this one before? The answer to this question determines what happens next, and it has a huge impact on performance. If the answer is yes, boom, we get a soft parse. This is exactly what you want. It is crazy fast. The database already has a pre-built roadmap for getting the data, the execution plan, and it just reuses it instantly. But if the query is brand new, that triggers a hard parse. This is way, way slower because the database has to build a whole new, efficient execution plan right from scratch. Okay, so we have a plan. The server process knows how to get the data, but the next big question is, where is it? Its first stop to find out is another part of the SGA, the database buffer cache. This is another one of those make or break moments for performance. The system is basically asking, hey, did someone else already ask for this exact piece of data? Is it already sitting here in our fast memory workshop from a previous request? If the data's there, we call that a cache hit. Perfect. That's like finding what you need on the desk right in front of you, super fast. But if it's not there, that's a cache miss. And that means our server process has to leave the workshop and take a much, much slower trip over to the permanent library, the physical desk. Okay, so let's say we got that cache miss. Now what? Well, our server process has no choice. It's got to go read the data directly from the physical database files, which are all stored on the disk. And these data files, you can think of them as the actual physical books in our library. They contain every single piece of data your application uses. But it's not just a messy pile of pages, oh no. Inside, it's organized in this really smart, logical way. So how does it do it? Well, Oracle uses this beautiful, simple hierarchy. It starts with the tiniest piece, a block. Then it groups those blocks into an extent. A bunch of extents make up a segment, which is basically a thing, like a table. And finally, you group related segments together in a table space. It's this awesome structure you can remember with the acronym BEST, block, extent, segment, table space. Pretty clever, right? Okay, so far we've only been reading data. That's the easy part. But what happens when we need to change something? You know, an update, an insert, or a delete? Well, that's when a whole team of specialist background processes inside the instance wakes up and springs into action to make sure nothing ever gets lost. Listen to this. Before a single byte of your actual data is changed in the library, a perfect record of that intended change is instantly written down in a special memory area in the SGA called the redo log buffer. This is the absolute safety net. It's the database's promise that once you commit a change, it is never, ever lost. I mean, the entire system could crash a millisecond later, and that change would still be safe because of this journal. And this is where the automated crew gets to work. First up, you've got the log writer, or LGWR. This guy's only job is to immediately write that journal entry to the disk. That's the moment your commit becomes real and permanent. Then, a little later, the database writer, or DBWN, comes along and efficiently writes the actual change data to the data files. And all the while, you've got other specialists like Checkpoint, SMON, and PMON working in the background. Think of them as the system's janitors and security guards, keeping everything tidy and safe. Okay, we've been on quite a journey here. So you might be asking, why? Why all this complexity? Why this constant back and forth between memory and disk? Well, it really boils down to three huge things. First, pure performance. Keeping data in that memory workshop is literally thousands of times faster than going to the disk library. Second, concurrency. This whole setup lets thousands of users work at the same time without tripping over each other. And maybe most importantly, reliability. That journal-first system we talked about means your committed data is just safe, period. And that right there is the genius of this whole design. It's not about choosing between speed and safety. It's about creating this incredible architecture that gives you the mind-blowing speed of memory while absolutely guaranteeing the rock-solid safety of the disk. It's a complicated dance for sure, but it's the dance that makes sure your data is always there and always fast.